Okay, so during this session what we'll do is we'll have a look at inherited disorders. Okay, so you should have had a look at alleles recently. In terms of a dominant gene, that's represented by a capital letter in a Punnett square, and a recessive gene is represented by a lowercase letter. So for example, brown eyes, that is the dominant gene, therefore we represent that with a capital B. Blue eyes is a recessive gene, and therefore that's represented with a lowercase b. If we have a look at disorders and inherited disorders passed on to children, polydactyly is caused by a dominant gene. If you're not familiar with what polydactyly is, that's extra digits, so extra fingers or extra toes. So let's have a look. Because it's caused by a dominant gene, a polydactyl parent will have a capital letter and either another capital letter, in this case they've got a lowercase letter, so this person will have extra fingers or toes. A non-polydactyl parent will have no example of the capital letter gene, so the dominant gene at all, so they're both lowercase. Okay, so in terms of it both being lowercase, they will have no extra digits. So if we have a look at the chance of an offspring having polydactyly, then here we've got capital B, lowercase b, capital B, lowercase b, so that's the information from one parent. We've got lowercase b and lowercase b, and the same again. So what I've done on my Punnett square is I've referenced these values: capital B, lowercase b, and lowercase b, etc. Therefore, the child would have 50% chance of being polydactyl. Okay? Now, the other inherited disorder you need to be aware of is cystic fibrosis. Now, cystic fibrosis is a respiratory condition that affects the lungs, and it's caused by a recessive gene. Now, if somebody has cystic fibrosis, then they've got to have double lowercase b, okay? So they'll have both recessive genes. However, a carrier, so you can carry cystic fibrosis without actually having it, they would have one recessive gene. So they wouldn't have it, but they would carry the gene. So let's have a look. We've got two carrier parents here, both capital B, lowercase b. Okay, so this one is capital B and lowercase b, following that through. That is lowercase b, lowercase b. This is capital B, and this is capital B, lowercase b. Now, if we have a look at this situation, the chances are this. Their child, being a carrier, is 50%. The child not being a carrier at all is a quarter, it's 25%. And the chance that the child has cystic fibrosis is 25%. So what are we doing about this? Well, you can screen embryos, so you can check to see if they have the disorder. There are ethical implications of this in terms of interfering with nature. One of the other aspects of screening is there could be false positives, so somebody could return a positive result which is incorrect, so therefore the parent may think that their child is going to have a disorder which they don't do. Or alternatively, there could be false negatives, so the child they think is not going to have the disorder, they're born with the disorder, which are things to consider when we look at the ethics of performing screening. Thank you very much.